we've had a chance to look at some of the features and functions of the SBC that you might utilize in your network. You might perhaps, as we mentioned, you may use blacklisting, you may not. You might use transcoding, you might not. Let's take a look. This slide is showing us where SBCs are located in the core network. Now, this is showing every single place you could have an SBC, not necessarily where you will have an SBC. So, coming in on the upper left, PSTN access, you might have an SBC. Now, often from the PSTN, you're going to have an application layer gateway, network gateway. Sometimes they use different names, but basically that gateway is going to convert TDM to RTP inbound. It's going to convert SS7 to SIP inbound. So typically you wouldn't necessarily have to put an SBC in the network coming in from the PSTN. But I personally saw a customer a few years ago that had purchased a gateway from a provider, and when that gateway got a 302 moved temporary message, it would completely freak out. So they had to put an SBC in the middle. Redirect messages are commonly used in SIP. So if we use an example of one time you might put an SBC on the PSTN facing side. Now, as far as the lower bullets, the lower clouds, residential access and enterprise access, you could have a single SBC delivering both residential and business customers. Or you could have it split so that you have one SBC for residential, one SBC for business. That's entirely a business decision you have to make. Are you going to have 5,000 residential customers on your best day? If so, it makes sense to mix them. Are you going to have 200,000 residential customers? In that case, you're probably going to need more than a single SBC for residential access. But in both cases, the residential customers and the business customers would hit the SBC as the point of contact. You can have SBCs anywhere you have different layers of network. In the upper right-hand corner, we've got it going to an intelligent network. This could be a peering partner. This could be somewhere you're going for a SIP handoff. You could isolate your network using an SBC between different customers. So the SBCs can be deployed in multiple places regardless of where they're deployed. Their basic function is to set up, support, tear down the phone calls and the associated audio streams. Now, the SBCs always supported multimedia. They always supported audio, they always supported video, but with many things, the marketing group gets involved and suddenly says, we're a multimedia SBC. Yes, and we always have been. Basically, we're just saying that we're going to bring the audio and or video up into the cloud, and you can stream that to the different parties involved with the multi-party session, whether that be a conference bridge, a video conference bridge, a video call, an audio call, etc. And again, we've already discussed NAT traversal, quality of service, and service level agreements, so I'm just going to go ahead and move on here. Okay, just some terms and concepts we've been kind of dancing around here. Session management involved the signaling and the media associated with particular call sessions. Network interworking, basically helping us to resolve differences of codec negotiations between the different endpoints. That might mean transcoding, that might be stripping codecs off, adding codecs into the SIP invite once it hits the SBC. We could put codecs into the SIP message that the edge device never submitted, because we know we're going to support those, so we're going to go ahead and insert those into the system. And if they agree on one of those codecs that the two endpoints never supported in the first place, we could enable transcoding to make that happen. Service level agreements, again, we talked about the quality scores, the quality measurements for your network. Resource allocation, again, just we're going to have to decrement audio sessions, video sessions from a call with regard to bandwidth as those resources are consumed for a particular customer, and then open them back up when that call is over. Codecs, I keep saying codec. I do not recall ever having specifically said that a codec is used to code and decode audio traffic. It's basically just identifying the particular specific mechanism that we're going to use to convert audio into actual packets and convert it back at the other end. Now the SDP portion of a SIP message, this is the session portion of the SIP message that would say, I, Eric's phone, support G711, G729, H.264, H.263. What audio and video codecs do I support? That would be transmitted out to the B party, and the B party would pick the first one that it could do. They would agree on the codec used as a function of the SDP portion of the SIP invite. Now Realm. Realm is interesting. Realm is a very simple concept. You're gonna have a port, physical port in the SBC that SIP traffic's gonna enter. It's gonna be LAN cable to your switch. What happens is we're gonna say that we're associating this physical hardware to this IP address range, and we're gonna expect that SIP signaling enters there. We're going to associate a VNet, a virtual port, to an IP address to a realm name. The realm name can be assigned to features and functions. What happens here is the IP address is received through the LAN cable on this IP address range to this port. The SBC receives the SIP traffic. The SBC is going to say, oh, I know this IP address, I just got a SIP message. What is the realm associated with that IP address, VNet, VLAN, etc.? I need to invoke this list of functions automatically. I'm going to invoke transcoding, I'm going to invoke blacklisting, I'm going to invoke this stuff. The realm is just a name. We create a name to assign to that physical interface, and then we can assign features and functions to that realm name. So we're going to have typically a system public realm and a system private realm. You could name them something else. The name doesn't matter. It's the intent behind the name. I want to enable transcoding. I want to enable blacklisting. I want to enable call and mission control, etc. You can assign those to the realm name. Additionally, routing can be assigned to the realm name. So you could say that when we receive traffic on this IP address, automatically throw that call over to the application server. Or it could be a situation where we receive traffic on this IP address, we want to look at the next hop information configured in the SBC to say, oh, we're going to go to this pair of application servers or this pair of application servers. That functionality can be assigned to the realm, where routing is a function of what address and port we receive the SIP traffic on. Now, as far as monitoring the SBC, if you have dealt with GENBAND in the past, SBCs that might be familiar to you would be potentially Jarrell, Annapolis, much older, Q10, Q20, Q21. They may have had the Q20 and Q21 might have had a T, a letter T after the name. T indicated that you purchased an SBC with built-in transcoding functionality. SBCs prior to release 10 typically used the RSM for a GUI interface. The primary difference here is SBCs on release 10 or higher support the distributed functionality, meaning audio is no longer handled in the same box doing SIP signaling. So the Q20, Q21, if they're on release 9.1, 9.2 or lower, typically would handle the audio integrated into the box, meaning a single box is handling both audio and SIP signaling. On release 10 or higher, we could have the Q20s or Q21s. They could still be doing media internally in an integrated mode, or they could be in a distributed mode, meaning the audio is going to a Q50. You wind up with individual blades and VLANs, and a Q50 could handle SIP traffic much in excess, audio traffic much in excess of what the Q20s and Q21s were capable of themselves. The biggest difference here between what you might be used to and the newer stuff, there is a parallel CLI interface we're going to look at here in a few minutes, and the GUI, the RSM, has been replaced with the GenView 1 EMS. It's actually a big step forward and fixes some technical issues we had with the RSMs. The GenView 1 EMS is going to allow you to manage all of your platform functions. So you can have multiple network equipment nodes being monitored by the GenView 1 EMS. So again, what we see here, the last slide was showing ISBC. I did steal some of my thunder from this slide, but what we see here is a Q20 or Q21 being used for signaling, SIP, media going to a Q50, and the GenView 1 EMS being used for management purposes. And again, obviously this occurred in release 10. So it's not that vastly different, the Q20, the integrated or the distributed, with both the integrated and the distributed. In integrated, RTP went to an IP address range that was serviced by the same SBC. In distributed mode, the RTP is sent to a separate external box with a lot more LAN connections along the top and a lot more blades. So obviously the Q50 can handle many levels of phone calls per second above what the Q20 or Q21 was capable of. But all of the same functions still exist. NAT traversal, transcoding, quality of service, IP layer rate limiting, shaping, all of that stuff is still the same. The biggest advantage of the distributed architecture is it allows you to break your SIP and audio planes. In addition, you can aggregate your audio paths as close to the edge network as possible. It just prevents having to backhaul some of that audio longer lengths of distance than you otherwise might need to. And with the Q50 could be servicing multiple Q20s or Q21s. So you could have many different Q20s, Q21s all coming into a single pair of Q50s. Or you could have a situation where the Q20, Q21s could try Q50 number 1 first, cluster number 1 first, cluster number 2 second, cluster number 3 third. Now, with this severing of functionality, there are some new terms that you probably haven't heard before. The ACS component is referring to the SIP signaling, advanced control software, and advanced media system, AMS, is a function of the Q50. This concludes this portion of this learning content. Please look for the next video in this learning series. Thank you for taking the time to view this video.